All right, we're looking at question 21 here. I'm going to go ahead and do the full mechanism on this to actually draw what's happening, because we got a weird thing going on when I have either under nucleophilic condition like I do in 21 and 22 under acidic conditions. All right, under nucleophilic conditions, very first thing that happens is the nucleophile will attack the back side of the ring. Now I'm going to draw out two temporary mechanisms and then erase one of them. I want to show what's going on with this. So I'm going to redraw this ring. I don't like that too. With this O right here. And I want to put that OCH3 down here. Now when this attacks, it can actually go to either side, either one of these two sides. It either goes to the more substituted CH or the less substituted CH2. And I'm actually going to draw out both, and then we're going to talk about which one is more likely. So the first one I'm going to do is have that kind of attack the left. When that happens, these electrons come up here. And we would end up with a possible intermediate. CH is still there, CH2 is still there, but this is now just to O negative, and the OCH3 is here. The other possibility, get rid of those two red arrows, and we're going to have the red attack the other side. Now it's attacking the back. Only one of these really happens because one of them's far more stable. And I want to draw them out, and then we're going to talk about why this one I'm drawing is the correct one. So I have the OCH3 and then an O minus. Alright, reason this one, the bottom one there, is more stable is that negative charge, that oxygen that's unstable, is near a carbon that is actually secondary. It's got two other carbons to it to actually share that load. The one up above, the oxygen's off of a primary one, so it ends up a little bit less stable. So the intermediate is more stable here because of where the O negative ends up. So I'm just going to erase this one because it doesn't really happen. And now, to this, I have the follow-up reaction where the methanol, and I'm going to draw it out more like this, ends up donating an H. Giving us the final product that has the OH from the epoxide part on the more stable location and the nucleophile attached to the least substituted one. And giving us a name of, let's see, that's going to be 1-methoxy, 2-propanol. And I'm going to go ahead and do 22 now, because a very similar product, but we're having, or very similar idea, except we're having acid added. All right, so on this one, our first interaction is a lone pair on this oxygen attacks that hydrogen and it kicks off the chlorine. Now any acid would do that, but the very first thing we're going to make, and just like that previous one, I'm going to draw that epoxide slightly different, but I'm going to go ahead and draw it in its activated form. What I mean by the activated form, that epoxide now has an H attached because that's what happened in that first step, and it is slightly positively charged. And this is what the methanol attacks, and specifically it's the methanol's oxygen that's going to do an attack. And I'm going to do the same thing we did up above. I'm going to draw both possible attacks. So I'm going to have the O go here and then kick this off, which would create CH3, CH, CH2. I just redrew that straight line. This has now got an OH attached to it, and right here in the middle, OH, all this is still intact, but it has a positive charge. And then my other possibility is have that nucleophile alcohol attack the right side and kick those electrons up, which would give us CH3, CH, CH2, now the OH connected here, and the methoxide, or the methanol, sorry, attached here with a slight positive charge. All right, interesting, for the exact same reason, we have a different one stable. So up above, we actually like to have that O negative on that more substituted carbon. Down here, we want the O positive on the more substituted carbon. Meaning this bottom one doesn't really happen because it has that O positive near a primary alcohol. This one at least is near secondary. But we're not done yet. We have to have, I'm going to have the methanol that's still floating around in there attack, pull off that proton, leave those electrons behind, giving us our final product, OCH3 is now on this one. And this is the alcohol. So 2-methoxy, 1-propanol.